Flight instruments provide the pilot with flight parameters. These instruments inform the pilot about the helicopter flight situation, such as whether it's climbing, turning, in every flight situation. In the helicopter cockpit, you will notice 6 important instruments. The typical arrangement of these instruments is as follows. We have the altimeter, airspeed indicator, turn and bank indicator, vertical speed indicator, artificial horizon or altitude indicator, and directional gyro or heading indicator. In its simple term, an altimeter or an altitude meter is an instrument used to measure the altitude of an object above a fixed level. The most common unit for altimeter calibration worldwide is hectopascal, except for North America and Japan, where inches of mercury are used. A standard altimeter contains a stack of sealed aneroid wafers with an internal pressure of 1013 hectopascal. These wafers expand and contract based on the static pressure inside the casing of the altimeter. The static air enters the casing through a tube attached to the static ports on your airplane. The chamber is otherwise sealed, so only static air from directly outside the airplane enters the chamber. A higher static pressure presses down on the wafers and causes them to collapse. A lower static pressure, less than 1013 hectopascal, allows the wafers to expand. This is according to the Federal Aviation Administration. Mechanical linkage connects the movement of these wafers to needles on the interior face of the altimeter. Compression of the wafers translates to a decrease in altitude, while expansion translates to an increase in altitude. The QNH and the QFE are pressure reference that you need to use in order to use your altimeter properly. Your altimeter feels the pressure around the aircraft using the static ports, and it also knows that for each HPA of pressure difference there is a vertical difference of 27 feet. In order to calculate its vertical distance, the altimeter requires a reference expressed in hectopascal set by you. Once the altimeter has its reference, it simply calculates how many HPA there are between the pressure reference that you set and the pressure around the aircraft. Then it multiplies it by 27, because for each HPA there are 27 feet, remember? The QNH in aviation is the pressure at the mean sea level. It varies quite often as the pressure in the atmosphere changes constantly. It's important to know what is the QNH of the area where you are flying, because you need to set it on your altimeter in order to read and fly altitudes. Now, I'm sure you are asking yourself, why do I need to fly altitudes? The answer is because when you are flying at low altitudes, below the transition altitude, you need to keep the separation between the other traffics and the terrain. The only way to stay separate from an obstacle is to use the same reference. So, since the terrain elevation is expressed in feet from the mean sea level, you want to make sure that you are using the same reference. The same is also true with other traffics that are flying like you below the transition altitude. If you don't use the same pressure reference at a mountain of 5,000 feet elevation, for example, you might read 6,000 feet and think that you are separated when maybe you are not, because you are not using the same reference. You can get the QNH from the METAR or ask the air traffic controller to provide it to you. The QFE in aviation is the pressure at your airfield. An easy way to remember what this pressure refers is, without making confusion with the QNH, is to associate the F for the QFE to the field. If you want to know your vertical distance from the terrain or the airfield, set the QFE on your altimeter. This pressure reference is not commonly used during flight operations. If you rotate the altimeter pressure reference knob until you read the airport elevation, you will get the QFE. Now, you know already that if you set the QNH that can be taken from the meter or the ATC, you will fly altitudes. And if you set the QFE, you will fly height. The QNE is not a pressure reference, it's the vertical difference expressed in feet between the standard pressure reference of 1013.25 hectopascal and the aircraft. We commonly associate the standard pressure reference of 1013.25 hectopascal to the QNE. However, this is wrong because it's not the pressure but it's vertical separation in feet. Once you pass the transition altitude, you need to change your altimeter pressure reference from the QNH that kept you separated from the obstacles and other traffics to 1013.25 hectopascal and flight levels. This will only separate you from other traffics, and let me explain. When you cross the transition altitude, that means that the terrain is no longer a factor, so you need to keep the separation with other traffics from this point. If you think a little bit, you can see that there is a problem here. For example, if I depart from Tunis with a QNH of 1020 hectopascal, for example, and you departed from Riyadh where the QNH is 130 hectopascal, what would happen when we cross each other? If you answer that we cannot keep the separation because we are using two different QNH, you answered correctly. That's why once the terrain is no longer a threat, we all use the same pressure reference, which is 1013.25 hectopascal and flight levels. Above the transition altitude, you won't know your altitude, but you will be able to stay separated from the rest of the traffics. So, as a conclusion, as you know by now, an aircraft flying on a level flight can have an altitude, a height and a flight level depending on which altimeter setting you set as a reference. The important thing is to know when to use the QNH, when to use the standard pressure and when to use the QFE.